Right, so now that we've done a hypothesis test for a mean, one of the big things that we noticed was that we can no longer use our z-table because we no longer have a z. So now that we have a t, we were using StatCrunch to help us calculate p-values. However, there will be times where you're not going to have access to StatCrunch, and we'll need to be able to figure out the p-value based upon some options that are provided for you. Now, in the first time we talked about hypothesis testing, we discussed what things we needed to calculate a p-value. We need our test statistic, which in this new case would be our t that we've calculated, and we need the sign of our alternative hypothesis, letting us know if we have a one-tailed test or a two-tailed test, or in a sense, how to draw our picture. So what you'll be given is 3 p-value options, one that matches each possible alternative hypothesis. Sometimes you're going to be asked to match all 3 p-values to the corresponding alternative or to choose the one that goes with the alternative that you have. So we're going to do this through an example. So suppose that we have our test statistic, or RT, equal to 1.42. And I give you 3 p-value options of 0.9175, 0.1650, and 0.0825. Now the p-value that you're given, you're going to be asked to match to the 3 options of an alternative hypothesis. We could have an alternative hypothesis that has a greater than sign in it. We could have an alternative hypothesis that has a less than in it. Or we could have the alternative hypothesis that has that not equal to in it. So by drawing the pictures and understanding the connections between these, you should be able to figure out which p-value is which. So we're going to draw some pictures. But I first want to point out that the 3 options you're given have certain characteristics that are going to happen. Notice how that 2 of them, here the 0.9175 and 0.0825, add up to 1. There will always be 2 values that are going to add up to 1. Those are going to correspond to your one-tail hypothesis test. One's going to be shaded left and one's going to be shaded right. The other value, which will always be double the smallest value that you have, so if you double 0.0825, you get 0.1650, will always be your two-tailed test. So I already know that this one is going to be corresponding to my alternative of a not equal to. But let's go through it and see if it makes sense as to why. So first I'm just going to draw all 3 pictures. So I'm going to put my test statistic on here, which was 1.42. Since my alternative here is just one-tailed, looking at the direction is a greater than, telling me that I'm going to shade to the right. Going on to my other one-tailed alternative, I have the same test statistic, but this time, since it has the less than sign, we're going to shade to the left. And then finally, our two-tailed one, we will also put our test statistic on here. But then I didn't care if I was above the mean or below the mean, so we're also going to look at that negative 1.42, and then I would shade my outer tails. Hopefully you remember doing this from our first time of doing hypothesis testing. So now, again, so what this two-tailed one is, it's going to be double, basically what this little one is here, because it has that same piece shaded plus another piece of the same size. So it's always going to be double the smallest. Well, as I just discussed that, I took double this one. Well, which one did I have to double up here to get the 0.165? Okay, so that one's going to be my 0.0825. How else we can notice this, though? If I look at my 2 one-tailed pictures, you're going to notice that one is always going to be smaller than 50% and one will be bigger than 50%. Because if I had everything to the right of 0 shaded, that would give me 50% or 0.5. Versus if I have more than half of it shaded, it's going to be bigger than 50%. And if I have less than half of it shaded, it's going to be smaller than 50%. So notice how these two numbers, one is bigger than 50% and one is smaller than 50%. So now I can go ahead and give you all my p-value answers. So the one here on the far left with the greater than sign is going to be our smallest p-value of the 0.0825. Now the one that adds up to 1 is our other one-tailed one, but this is also our only one here that is bigger than 50%. But it's easiest again to find that two-tailed one first because it's double the smallest, so it's going to have our p-value of 0.1650. Let me also demonstrate this in StatCrunch like I did the first time we did hypothesis testing. So for this, I'm just going to be using some data to get the values to match here in StatCrunch. So I'm going now to T statistics, one sample with summary. Suppose I had a sample mean of 24.653, a sample standard deviation of 15, and a sample size of 34. And these I'm also putting here on the side in our notes, so if you want to do this in StatCrunch yourself, you can get it to match. So here's the values that I'm using. Next, though, I have to have some hypothesis that I'm testing. Suppose that our null hypothesis is that the mean is 21. And again, just putting that there for us. Well then, based upon my alternative hypothesis sign, the only thing that changes in my output will be that p-value. So if I leave it as that not equal to, I believe then I should get a p-value of 0.1650 from what I've drawn here with my pictures. Notice that that is what we got. And there's that t of the 1.42. If I change my alternative sign, again, the only thing that's going to change is my p-value. If I change it to the less than, I believe I should get 0.9175. And that is what we get. And then for the greater than sign, we get our 0.0825 that we had here as well. So again, those three p-value options given to you will always be for one of those alternative signs. Let's look at another example. Suppose this time that my t is negative 2.11, and my p-value options given to me are 0.0484, 0.9758, and 0.0242. Now with what we just learned from the first example, notice that two of these add up to 1. And these are going to be my one-tailed. One of these is going to be a greater than sign, one of them is going to be a less than sign. And then this one is our double, the smallest one that we got. So that one, again, I already know is going to be my not equal to. Now you might have a gut instinct of which one you think is which one-tailed, but let's draw out the picture to make sure we're feeling okay. So suppose, just as above, my first one I have for my alternative is a greater than sign. So I would take my test statistic, which is negative 2.11, and because of the greater than sign, I would shade to the right. If instead my alternative was a less than sign, I would shade to the left of our negative 2.11. And then finally, with that not equal to, even though we already know which p-value goes with it, I would have the negative 2.11 and the positive 2.11 with my two pieces shaded. So So by looking at the picture then, which one is this double of? Well, it's double of this one. So it's going to be my small piece. Again, also, this is one that's less than 50% because I can tell that less than half my picture is shaded. And this one is going to be greater than 50% because more than half of that picture is shaded. So then my answers here, so this one is going to be the 0.9758. This one's going to be the 0.0242. And this one's going to be our 0.0484. So again, the one that's always double the smallest is going to be your two-tailed p-value. To figure out between your one-tails, you're going to want to either draw your pictures or understand what that your test statistic being positive or negative means. Notice up in this example, when our test statistic is positive and you have a greater than sign, then it's going to be less than 50%. But if your test statistic is negative and you do a greater than sign, your answer is going to be bigger than 50%. So your sign of your test statistic is also going to be important when trying to figure out which one is bigger or smaller than 50%. So for a lot of us, I think drawing the picture can be most helpful with that. So hopefully that clears things up on how to sort of figure out your p-value based upon your alternative hypothesis.